This is a tutorial on the concept of Euler angles, which is available as an option in the access system for Catia v5. The particular tutorial that I'm going to do was actually prepared on v5 release 2021 or v5 6 release 2021, but I'm pretty sure you know that in the past 20 years, maybe 25 years, the interface of this CATIA has not changed. Okay, therefore it really doesn't matter. Okay, when you're doing a part design, for example, you create a part. Of course, the default global coordinate systems are used as the access for the part, global XYZ. But it may be that you want to create your own access system, and that's what I'm going to be concentrating on. So in the part design at in the utility menu, you have tools, and then there's this icon there which says access system, and when you click on it, this dialog box opens up. Now notice that for the this access type system right here, access type system, there's a pull down menu. The default is standard, so it's going to be lined up with the global XYZ coordinate system. But you have three other options, and one of them is Euler angles. Okay, now the axis of rotation and standard are fairly easy to manage and understand, and even if you went to the help or documentation, it tells you pretty good what to do. What it doesn't do is giving a meaningful explanation of what that Euler angle option does. Okay, so I'm here. I'm going to select the Euler's angle option. So this is what I get. And then I have to notice that I can select, of course, the arbitrary point, but I'm not going to worry about it. I'll use the global origin because it's easier to see what's going on. And then you have to input three angles: angle 1, angle 2, angle 3. So what exactly is it that it's going to do with these angles? So let me point out that the version of Euler angle that's incorporated in CATIA v5 is what is called 313 or ZXZ Euler angle sequence, because there is 12 different Euler angle sequences, but the one that's programmed or available and cannot be changed within CATIA is this 313 or ZXZ. Now notice that what you see here is the global direction. When you create an access system, it automatically places XYZ access system aligned with the global, and I've shown it here for you. Okay, now that's the same one as before. This is the same one that I just showed you. Suppose I put a 90 degrees for angle 1. What does that do? Let me show you. I put a 90 degrees. Notice what it did. It changed things. The original Y was going to the right. Now it's going backward. So what happened here? So sequence ZXZ means that this first angle that you put in there is a rotation about Z axis, the Z axis that you have. Now, this is what we had here. We had the original situation on the left side. So you rotate this about the Z axis, original Z axis, and notice that when you do that, when you take the original coordinate system and rotate by 90 degrees about the Z axis, the X is going to be moving to the Y line, and the y axis is going to move to the back aligned with the x. So this is the result of rotating the z axis by 90 degrees. Remember, z x z 313. That's what it's doing. All right, so that's what it did. Now suppose for angle 2 I keep that. Suppose for angle 2 I put 90. So let's see what happens. Notice that it's changing. What happened? It went to the previous coordinate system that I have it on the right side. It went there. it rotates by about the x-axis. Remember, z, x, z. We already did the first z. Now we're doing x. It rotates about the new x-axis. This is the new x-axis right there. Okay? The new x-axis. This was the new x-axis right there. See that? This is the new x-axis. It rotates it by 90 degrees. So what happens when you do that? This z is going to become horizontal. You can see that right there. And the y is going to point up. The y is going to point. Of course, x doesn't change because we're rotating about the x-axis. So suppose I go and put a 90 for angle 3. So what does that do? It takes the new z-axis that was created, which was right here, the new z-axis right there. It rotates that by 90 degrees, plus 90 degrees. So what it does is that x will go up and y go to the left. And there we are. X goes up, y goes to the left. So I just showed you one example. You want to do another example? Let's go ahead here. Once again, you click on the axis system. It creates a global coordinate system, aligned with the global coordinate system, an axis system right here. Now, suppose I put a minus 90 for z-axis here, angle 1. What does that do? It goes to this axis system over here on the left. It rotates the system by minus 90 degrees. When you rotate this by minus 90 degrees, obviously y is going to go in place of x, and x is going to go to the left. You can see that, aligned with the original y. So this minus 90 degrees, it went to the new z-axis, which is exactly what we did initially. Initially, there's no new. That is the new, okay? And rotate that z-axis, about that z-axis for minus 90 degrees. Suppose I put a 90 here. Suppose I put a 90 for angle 2. So it goes to the new x-axis. Remember z, xz, or 313. It goes to the new x-axis, which is right here, and rotate the system by 90 degrees, positive 90 degrees. So y is going to go up, z is going to go to the back, right here. Z is going to go back. Now, suppose I put another, let's say another minus 90 degree for angle 3. It goes to the new z-axis, which is right here, new z-axis right here, and rotates that by minus 90 degrees. If I put a minus 90 for angle 3, it rotates it by minus 90. So what happens is that x is going to go down, and y is going to go in place of x, right there. You can see that. Of course, z doesn't change, z-axis doesn't change because we are rotating about that. I want to do another example. Once again, I click on the axis system. It creates a default one as shown on the left. Suppose I put a 90 for angle 1. We have already done that. We know what's going to happen. So it goes to this axis system right here. It rotates about the z-axis, but by plus 90. If I do that, so what happens, y is going to go to the back, x is going to line up with into the right there. You can see that x lines up to the right, y goes in the back. Now, suppose I leave angle 2 alone, and I put a minus 90 for angle 3. So what does that do? Remember, z, x, z. So it goes to the new z-axis, which is right here, and rotates it about that z-axis by minus 90. So if you do that, x is going to go back to where it was, okay? And y is going to go back to where it was. It's right here. We started with this. We end up with the same thing because of what we just did. So the moral of the story is that this is the sequence of rotation, 313 ZXZ, and it always rotates about the new axis system that was created because of that rotation. The only exception is the first one. The first one is, of course, there's no new. That is it. Okay. Documentation in the Catia online, sites. This is what you get. It's not very helpful, but it has the elements of what I just told you. So remember, ZXZ. So the first angle that you put in there is rotation about z-axis by that angle. This is what this diagram means. Notice that if you rotate about this original z right here, vertically up, by an angle, this x will go to another position. This x-axis will remain in that same plane xy, but it goes to a different position. And of course, when you do that, so obviously the y is going to move too. The y is going to be this. Okay. Now, when you put your second angle, it takes the new x-axis. Remember, z-axis. The second angle corresponds to the new x, which is right here. Right here. You rotate about this by angle 2. So what happens is that this stays the same, z tilts and goes to a new position, w. And finally, the third angle is rotation about this w axis by that angle 3. And this is what happens when you rotate about the w axis or z. This is the last one, z axis. This line is going to go to some other line which is shown here. So that's what this really means. It's kind of hard to figure out from this diagram what's going on, but those two examples, three examples actually should clarify the situation. The reason I selected 90 because you can see it. If I had done something like what you see down in this diagram, it's kind of hard to see what's going on because this becomes a three-dimensional view at arbitrary angle, which is kind of hard to keep track of. That's pretty much it. I have the corresponding video for the 3D experience Catia, which was also uploaded in my website or in my YouTube channel. Good luck.